Thanks, everyone. This is a great opportunity for us to publicize some of the work that we're doing using PBS Professional on our prime HPC system at NCI. This slide's jam-packed with sort of PR material, but the takeaway items to mention are that NCI operates Australia's largest HPC facility, and in fact, it's the largest system that's operational in the Southern Hemisphere. The drivers for our why we're there is largely science-driven. We're focused around research outcomes and supporting researchers all around the country. The NCI is actually funded through a government research framework, similar to what you'd see here in the U.S. from the NSF. NCI isn't just a standalone facility with a big data center. We have partners spread across the entire community of universities and government research agencies in Australia. This slide shows sort of a look at all the logos of the various institutions and so on. A couple of years ago, this slide would have been much sparser, and as I'll talk more about as I get into the presentation, one of the issues we've been dealing with is very rapid growth in our user base, and keeping everyone productive and happy. And training, a particular challenge has been training new users as they've gotten into HPC. So our current peak system, Rodger, it comprises about 84,000 cores. The main component of the system was procured in 2013, and that system comprised about 57,000 cores, and was recently supplemented with an additional build out of about 23,000 cores of Broadwell nodes. At the moment, the system has about 330 terabytes of main memory, FDR InfiniBand, and about 10 petabytes of dedicated storage. The graph in this slide shows the sort of development of HPC in Australia over time. NCI is actually, or what became NCI, started very early in the late 80s with procurement of various Fujitsu HPC systems, and at that time was known as the ANU Supercomputer Facility because it was based at the Australian National University. So the line there in the graph clearly shows growth. We've been through several name changes over the years, but now we're one of two. We're the largest, but we're one of two major sites within Australia, the other one being the Pawsey Supercomputing Centre in Perth. So, as I said earlier, we're not just there to have a big iron data center facility. We're there to support research. The people using our systems range from the purely academic all the way through to industrial customers who in effect use us as a pay-as-you-go service. As of today, we have about 4,500 active users across Australia, and about 1,500 active projects. All of the use of our systems generates about 1,500 scientific peer-reviewed papers per annum. Currently, our HPC, the HPC component of NCI has about 25 staff. In the user support group, we have 8 people. working in that group. The user support at NCI is more than just in effect IT support. It's each of the people in the group has an academic or a research background of some type, and the staff scientists in the group are able to work with various people in the user community to help them come on board, help them with particular problems, improve code performance and workflows on the system. We also have another division located in an adjacent building that has a large focus around big data and data-centric work. This slide is just a quick overview of the main elements of Rodger. I think the key thing to note is that the large Lustre file systems that we have, the GData and the native file systems on Rodger are all are available across a number of services. The connections to the private cloud and OpenStack systems allow people to do things on Rodger and then have data-centric work happen on either of the public or private clouds. The user base on Rodger is heavily tilted toward the earth sciences application areas, but is now, we see a much wider spread of applications today than you would have seen, say, 10 or 15 years ago. So that user space has become much more diverse, and the skill level or experience level of the users has really changed, is much wider. We have everyone from the hero level expert users who can utilize the entire machine, and all the way through to absolute beginners who are just learning how to write code or just run applications. Many people we see in our training. We have a lot of new users who are not familiar with the Unix command line and things like this. They just want to run applications. So one of our challenges has been to try to address this diversity in our user community. This slide, you probably won't be able to read this, but the key things to note are the graphs, the distribution of jobs on Rodger. So the blue area on the left graph is a look at jobs that are just utilizing a single CPU. So that's a fairly, I mean, it's in the neighborhood of 50% of the jobs running at any one time utilize just one CPU. These will typically be these beginner or smaller scale users that I mentioned. On the right-hand graph shows the distribution of jobs by, or the consumption of CPU hours by jobs against the size of the job. So the actual resource is being used mainly by that green band across the middle of the graph, and that green section shows jobs that are in the size range of 128 to 1,024 CPUs. So that's sort of the sweet spot that we have in terms of of utilization of the system. So with regard to Rodger, we use a version of PBS Professional that has some customizations. A job prioritization daemon implements NCI's own fair share algorithm. The algorithm is set up to favor large jobs. We want to encourage people, or we want to make it easy for people who need to use the full capabilities of the system to get the best value out of it. We also want to keep the smaller users happy and able to get things done as well. Another important element for us, and this is with regard to the data work that I just mentioned earlier, data transfers are done through special data mover nodes, and these incorporate some customizations on a fair share scheduler as well. Okay, at the moment, so I'll talk now a little bit about specifics about what we see in terms of use on the system. Rygen runs about more than 1 million jobs every month. So the scheduler, and I apologize, there's a typo on this slide. The scheduler actually has a fair amount of work to do. Internally, we have very strong interest in looking at multi-scheduling solutions that Altair has been looking at. And one of the questions that pops out of this is that it'd be interesting to know if the server could handle such loads, that sort of load, and be able to cope with a multi-dimensional types of scheduling. Another thing that we hear from many projects is that an important thing that we hear from lead CIs on various projects is that they would really like the ability to set priorities on jobs within among their own project team. So this is something that was available on a system. A previous system that NCI, or what became NCI, operated. But again, this would allow some of our bigger stakeholders to control, to manage their throughput and workload. A really big item for us at the moment is resource accounting. We've gotten off to a great start with what we have, but we're really feeling the need to improve things and take them to the next level. Our accounting is becoming increasingly more complex and difficult to manage. The lack of a database behind the accounting system is a serious limitation that we're struggling with, and we're also looking at cases where we really need analytics and the ability to invoice or report in a very painless way. One thing that the HPC team is very interested in is having if there are mechanisms to allow accounting data to feed back into scheduling decisions for jobs. That's offers some intriguing possibilities to maybe be more innovative in terms of job scheduling. So in terms of requirements, we really absolutely have to have something with an API. Without an API, we're hamstrung in the sense that it's very difficult to develop useful tools around accounting. A database, again, is critical. We would also like, at the moment, what a user sees is the user's ability to get information is very limited, and that's something that we're really looking to try to improve. We also need to improve our administrative tools. Another thing that's very important is job history information, and we typically do this sort of thing through independent means, but it's very important for us to be able to go back to certain users who aren't using the machine efficiently and to provide them advice on how. First of all, let them know what's going on with this newer, younger, less experienced group of users. Often they're not using things in an efficient manner, and we need to educate them and help them make better use of the resource. A really big step for us would be to have a system that we can integrate with our online self-service registration portal. So a big service improvement for us in the last year and a half has been the release of a self-service facility to allow users to register and propose new projects. The system also allows the lead CI of a project, that is someone out at a university or government research institute, to effectively manage the membership of their own project team and take care of, very easily manage their project memberships without sending any emails or having any communications with us. This has been a huge time saver for us, a huge efficiency gain, both for us and the users. And the plan for us is that we call it Mancini, Mancini will become the single one-stop shop for NCI users. But the next step that we need to take is to get accounting information available to us and the users in that system. So I should also mention why accounting is actually important. I mean, this will be obvious, I think, to everybody, but NCI grew. What became NCI started as a purely academic, sort of very friendly, club-like environment, and through the years has become successively more of a business-like environment. We need to manage the resources. Our stakeholders need to manage resources, and we have accountability. So we need to have systems that give us a full view of everything. The key thing that we're dealing with is our user community is quite large, and it's complex, and it continues to grow. We've had very rapid growth in the last 2 or 3 years. At the moment, and these numbers will differ a little bit from the earlier slide, we have about 4,800 active users and about 1,500 projects. There's a little bit of cruft in these numbers because of training accounts and various things, but these are very, very close to reality. We see about 5 new user registrations every week. That depends a little bit on the season, the time of year, and what's happening. We have 29 major stakeholders. These are government research agencies. Most of the Australian university sector is a partner with us in one way or another. A new player in the partner space are medical research institutes. These are agencies that HPC typically has not, in Australia, have not been. Medical research institutes have not been large HPC consumers in Australia until recently. There are a number of university consortia as well, and ARC Centers of Excellence. The ARC, Australian Research Council, is an organization very similar to the National Science Foundation here in the U.S. And a new and rapidly growing part of our user community are industry partners. So these are paying customers. They sign on. We offer a pay-as-you-go service, and we send them bills every quarter. So that in itself, it sounds really silly, but that step is something that an academic that you're not used to doing in an academic environment at all, and to be honest, it's something that we're struggling with. We're not well set up to do the very simple process of sending someone a bill and managing the payment of that. I've got a number of slides that break down our stakeholder space a little more clearly. I'll burn through these very, very quickly. This is probably the most important one. The major partners that we have are the Australian National University. This is partly through just placement. What became NCI or the first two HPC systems in Australia in the 1980s were placed at the ANU, and through the various, what became NCI has been located there and has changed names several times over the years. Our current other major partners are the Australian Bureau of Meteorology and the CSIRO, Commonwealth Science and Industrial Research Organization, and Geoscience Australia, which is the Australia's equivalent to the USGS. So between all these partners, these use about half the machine, or they're entitled to use about half the machine. So I also mentioned university partners. They're many and growing. There are also interconnections through various funding programs and consortia relationships. I won't run down the list there. Centers of excellence are a very important part of our user base. In fact, Rygen itself was procured largely, the procurement was aimed at satisfying the requirement for a peak facility to carry out climate work. And so that the Climate System Science Center of Excellence was one of the leaders in that. But you can see the various fields there on the list. Medical research institutes, huge part of our current and growing business. A different class of users altogether, very different than traditional HPC. The HPC community. So we're having to learn how to do some new things and keep these people productive, and our industry partners as well. I'll just briefly mention that we also run a national merit scheme where there's open competitive peer-reviewed program. NCI, in fact, our team manages the execution of this scheme every year. It takes up about 2.5 to 3 months of our time. It's a very labor-intensive process, but the demand for these open competitive resources is very high. We typically get on the order of 300 applications, and the demand exceeds supply is by a factor of about 3.5. What makes it interesting from an accounting point of view is that when these allocations have been made, these allocations can be mixed in with allocations from the other stakeholders, so that it's not just a flat linear allocation world. It's very, very interconnected and mixed. So that's one of the challenges that we face. At the moment, we do okay with it, but we need better tools. We need to write some better tools to make it easier. I won't talk a lot about the actual mechanics of this, other than that the key thing is that to mention these multiple stakeholder allocations. I work very closely, or our team works very closely with each of the agencies I've listed so far has appointed an allocation manager, or a scheme manager, as we call them. So our team works very closely with these individuals to help them make decisions about how to allocate resources. Some of them are very hands-off. They just set things in January and forget about it, and everybody, all of their researchers are happy. Others are extremely dynamic and frequently adjust things on a say a monthly schedule to maximize the utilization of their share. So this is a new development in the way that we've conducted business, and we've had to do this just to cope with the expanding size of the user space. So at the moment, our resource accounting is based around, AllecDB is standalone on Rygen. A couple of commands allow users to look at what they're allocated and what they're using. We use utility scripts with a few wrappers to set and modify things. Our actual accounting data are visible through a separate system that's standalone from our registration and other tools. We also are strictly we need to do much better automation. The key thing at the moment is that we really don't have the ability to integrate things very well, and information is spread across 3 or more systems depending on what you want to do. So where we're looking, this is really a time of great opportunity for us, in the sense that if we don't innovate, we'll be in trouble. So we really need to build in a proper database behind everything. We need something with a resource accounting API that would allow us to kind of really, that would open the doors to many useful tools and integration with the Mancini registration system. As I mentioned earlier, the HPC team are looking at scheduling with some sort of active feedback from the resource accounting. That would be a particularly useful thing to do. We need to improve our automation all around. Reporting and invoicing sounds very pedestrian, but absolutely critical. Where we'd really like to go is to have self-service provisioning and allow the stakeholder or scheme managers to do that through the Mancini interface. So the way it's done now involves a lot of decision-making, emails, phone calls, and so on. We would really like to provide each scheme manager with their own web page and allow them a set of sliders or dials and allow them to just change the allocations as they need, and to get an accurate view of how things are tracking under their scheme. It would be really great to give them a dashboard if possible. The other piece of it, I mentioned briefly the merit allocation process. This is a different spin on the same idea. We have additional systems that support the merit allocation workflows. It's very easy to capture an application for a proposal for one of these merit schemes, but the difficult part of that is supporting the merit committee assessment and allocation, the actual decision making. So that's something that's probably worthy of a talk all on its own. There are really no good off-the-shelf solutions for that, so we will have to build something. So that's really all I had, and I'm just a couple minutes over the scheduled time. I'm happy to take questions, but I'd also like to mention that much of what I'm saying here is not just me. It's provided by our director, Lindsay Boughton, Alan Williams, my boss, Mohammed Atif, and Andrew Wellington from the HPC team, who some of you may have had more interaction with previously. I just want to say thank you, and I'm happy to take questions if we have time.
Sure, I think we probably have time for one question if somebody wants to, or we'll pull ourselves back on schedule. I'm scanning, raise your hand. Okay, thank you very much.
Okay.